Hey everybody, this is the second part of the 2.1 notes. The focus today is going to be on calculating proportions under a normal curve using a calculator. I just want to kind of quick go over yesterday though, we talked about this empirical rule, and these were approximate percentages for what percent of values or what proportion of values observations fall within 1 standard deviation, 2 standard deviation, and 3 standard deviations. Now, if you haven't looked at the guided notes I posted yesterday, and they'll be posted today, those guided notes also include a normal curve like this with individual breakdowns. So rather than just 68, 95, 99.7, that picture, the second picture in the guided notes that I included has these broken down further. And I can actually show you that real quick if you haven't noticed it. So here in the guided notes, and again, if you're at home right now in quarantine or out with COVID, you could fill these in at your own pace. Just pause the video at any time. But yesterday, when I talked about this empirical rule, I included in the guided notes a second normal curve broken down further. So for example, empirical rule says 68% of values fall within 1 standard deviation of the mean. So on this second curve, that 34 and 34, that came from half of 68. Yesterday we said that 95% of values fall within 2 standard deviations of the mean. Well, this 13.5 and 13.5%, they came from kind of taking this whole 95%. I punched out the middle. I punched out this middle 68% and then divided that by 2. That's why these 13.5% came from, and so on. So this same curve from yesterday I have in the guided notes broken down into little sections. Now the problem with yesterday and talking about this empirical rule is I can't find any proportions unless they are related to the number of standard deviations from the mean. So today, and the notes we're going to focus on today, we look at ways that you can find areas other than ones restricted to number of standard deviations from the mean. So for example, this was that same problem from yesterday. I think the kids were from Gary, Indiana, scores on some vocab test. Well, yesterday we could have found, well, the mean is here. I can know about what proportion are, let's say, between 5.9 and 8.39. That would be about 68% of kids would score there. Or I could say about 50%, right, are below the mean, or 50% of kids scored worse. 50% of kids scored better. So as long as I had these standard deviations in the mean to work with, I can use empirical rule. However, if I go ahead and throw a number like 6 in here, I want to know what proportion of kids that took this test scored 6 or less on this test. I can't do that with empirical rule because 6 isn't a specific number of standard deviations from the mean. No big deal. We have calculators that'll do that for us. So let me show you a couple other things first, though. So before calculators, or back in the old days, I think when I probably had to do this, we had to convert everything to z-scores. And we already know that z-scores represent average distance to the, a z-score is the number of standard deviations above or below the mean. That's what we defined z-scores to be last week. So the z-score formula is specifically related to something called a standard normal curve. So any scores, like here, these are ITBS vocab scores. I could convert ACT scores. I could convert heights. I can convert weights. I could convert, almost any normally distributed variable I can convert to a standard normal distribution by using the z-score formula. And standard normal distribution is defined as a normal distribution with a mean of 0 and a standard deviation of 1. Back in the old days, you needed to standardize to find proportions under the normal curve. However, with technology, the calculators we have now, you don't need to standardize. I still include this definition because if you're ever asked for the proportion of values under a standard normal curve, or if you're ever asked something about z and the proportion of values, you know you're dealing with this specific normal curve, the normal curve with a mean of 0 and a standard deviation of 1. So let's see how you can find areas, and I'll kind of go through both ways. I think the Khan Academy you'll have on Monday will go through the old way using z-scores and using a standard normal curve. So it doesn't hurt to see it. We're going to have a shorter, easier way with technology. So to find the areas, what we're always going to start off doing, you'll get sick of drawing these, is we're going to draw a normal curve and we're going to label it. So we're going to start off drawing a picture of a smooth normal curve like this. We're going to draw a bare, naked normal curve. And then we're going to add in the mean and write the standard deviation. We don't have to label them all like we did with empirical rule yesterday, but we do want to make a note of what the mean is, put it in the center, and then make a note of what the standard deviation is. We're also going to label on that curve the value we're interested in. So for example, in this last picture, if I were to kind of start this from scratch, if I wanted to know the proportion of kids in Gary, Indiana that scored under 6 or 6 or less, I would draw this curve. I would label the mean. I would write the standard deviation. I usually write it below it, and I'm going to do an example here in a second. And then I would draw my line at 6, and if I'm interested in less, I will shade to the left. So here is my picture. And then in the old days, you'd have to go to a z-score. I'd have to standardize into a z-score and then use a table of z-scores. We do not have to do this anymore. I'm about to cross that out. Cross that out. We are not going to use a table to find z-scores. We're going to use technology. And I mentioned the Khan Academy will do it this first way. However, if you have a calculator or an app, so even if you're at home, you can download the app Calculate 84. It works the same way as a TI-84. You can find these areas that way. So we're going to, again, draw, label, and shade a curve. We are going to use technology to find that area, and it's actually very simple. And then we're going to answer the question that was asked. So I'm going to leave this guided notes for a second here, and I'm going to go back to the guided notes I gave you, and we're going to do a few of those examples together. All right, so here I am. I'm back in the guided notes that you should be kind of filling as we go here. We just went through these steps in the PowerPoint. And notice in the guided notes, I have instructions on how to do this in a calculator. The inspires we use in class will follow these steps. On the TI-84, if you're at home, or this app, again, Calculate 84, it's a free app. It'll work just like a TI-84. These are the steps we're going to follow, and I'll show you both. So let's go ahead and kind of chip away at a few of these examples. I'm not going to do them all, but find the following areas under the standard normal curve. And remember, to be standard normal, that means we have a mean of 0 and a standard deviation of 1. And what these standard normal curve shows is really a distribution of z-scores. So I'm just going to do a couple of these. I'm going to do one. I'll do 1, 2, and 3. Or we'll see, maybe 1 and 3. All right, so I want to know the area under the curve less than z equals negative 0.4. So I'm going to go ahead and start off. I'm going to draw my curve. I'm going to label the mean. For standard normal, that's 0. Now, z equal to negative 0.4. Well, if 0 is right here, negative 0.4 is somewhere over here. It doesn't have to be to scale. I just know it's to the left. So that's negative 0.4. Sorry, I'm using my mouse to write. And less means that I'm going to shade left. So all of this is shaded. I want to know, what is this area? So my calculator can find that area for me, and I apologize. Let me go ahead and write the standard deviation as well. So the mean is 0, standard deviation is 1. I'll just write them both up here, because I'm going to need that when I fill in the calculator. Oops, I wrote mean is 1. Sorry. That's a 0. All right, so in class we'll use the inspires, but since you're at home, you either have an 84 on your computer, or maybe you have a regular 84. Or again, the app Calculate 84 will do this as well. So if I go to find this norm CDF is called, I go to second, VARS, and then that second option, norm CDF. This stands for normal cumulative distribution function. So it's going to find cumulative means area. So that's why I want the CDF. Now when it says lower, that means left shading. So the furthest left this shading goes is forever. I mean, the normal curve really gets infinitely close to this x-axis, so I want negative infinity there, and that's what this means. If you're confused ever how to type that, or if it doesn't show up, I always advise to call George Sink. George Sink, if you saw those commercials, is dial all nines. So you could always just type negative 9999999, a bunch of nines. The upper bound here is how far right does your shading go? So if I go back to my picture, well, my shading gets cut off at negative 0.4. So I put that in the calculator. It automatically sets me up for standard normal. That's what I am. And then press enter. So the area under that curve is 0.3, I forget what they were, 45. Let's look at another one here. Let's look at 3. I'll just jump over here to 3. I want standard normal still. I want the area between Z is negative 0.25. So here's 0. It's my mean. So the mean is still 0. Standard deviation is still 1. And I'm normal. So negative 0.25, that's somewhere over here. And 1.5, that's somewhere up here. Doesn't have to be drawn to scale. So now I go to my calculator. So you guys at home are using the 84. And again, to find this norm CDF, I go to second VARs and pick option 2. So my lower bound now, the furthest left the shading goes is negative 0.25. And then the furthest right my shading now goes is 1.5. I'm still standard normal, so that's a mean of 0 and standard deviation of 1. And my area ends up being 0.532. Double check, 532, yep, the rounding. Rounding wise, I always prefer 3 decimals. I think the Khan Academy you'll do Monday says 2 or 4. But 3 or 4 is fine. Just make sure you round correctly. I'm going to do one more. Let me do this number 2. So again, I sound like a broken record. Still standard normal. That means the mean is 0. Standard deviation is 1. And this time I want Z is 1.65 and I want to shade greater. So greater is above 1.65. So I go back to my calculator. I press second VARs, option 2, norm CDF. And I look, well, the leftmost shading here is 1.65. So that's my lower bound. And then my upper bound, this shades forever. So really any large number is good enough, but I recommend calling George Sink. So if I want to shade to the right forever, I'm going to keep going forever to the right, I'm going to go ahead for that upper bound and type all nines. I'm going to leave the mean as 0 and the standard deviation of 1, because this is standard. And my area there is 0.049. Now I could have given these as percent, so I talked about rounding. If I wanted to give these as percents, just remember you move the decimal twice. So if you want to give it as percents, this one would have been 4.9%. So what that means is 4.9% of all Z-scores are greater than 1.65. I could have made this one into a percent. I could have said, well, 53.2% of all Z-scores are between negative 0.25 and 1.5. I'm going to stop this video now. I have a 15-minute time limit. I'm going to make a second video, and then I'll post that as well. We'll look at, well, what if it isn't standard normal? And we'll also look at what if you have to work backwards.